Okay. You happen to have it? Or I just grab a text.
I have it.
Oh, it's on my textbook. You got it?
Oh, yeah.
That's fine. Just read it to me again.
From the quadratic equation with integral coefficients having different roots, and then it's -2 and 5 over 2.
I got an answer. I just wanted.
So these are the roots right here? Okay. And it says find a polynomial that has these roots and determine the integral coefficients. Let's start with that. Integral coefficients?
It just means that it's even a number.
Good. We're looking for coefficients for A, B, and C, those parameters that are whole numbers. Very good. So we can start by looking, do you remember from 7-7, sum of roots and product of roots? The sum of roots equals, always, and the product always equals? Yeah, that's the key to this problem. By doing that, that's the approach I would take, and then I would clear it out by multiplying by whatever denominator I had there. So I would start with the sum of roots being, let's see, -2 and 5/2. 5/2 is 2.5 and -2 is 1/2. So the sum equals 1/2. And I leave it in fraction form. It's very useful because the sum of roots is -b over a. So I can already say something about this right here. See what I'm saying? Then I go to c over a for the product of roots. The product of these two, the 2's cancel. I'm left with just -5. And that's c over a. So the problem that a lot of students run into is this. They look at these two statements and say, how could A be 2 and how could A be 1 at the same time? It doesn't make any sense, right? So what do you convert this fraction to?
-10/2.
Make this -10/2, so you have the 2 in both denominators for the A value, and then you know that A could be 2. It might reduce in the equation later, but it could be 2.
I solved this by a different method.
You could use another method. You could use x minus one root, x minus the other root, and then factor, and then FOIL it out.
No, I looked at like the examples in the textbook.
Okay.
I did like x squared minus r1 plus r2x plus r1 r2.
That's what I'm saying. So what you're doing, Regina, is exactly what I said. So you can use this form right here, which is what you get when you just said is what you get when you FOIL it out. So that's the form you have. Yeah, it's a much easier form than you did x squared minus x1 r1 minus x2 r2 plus r1 r2, like a longer equation, right? Kind of like that's what you get when you FOIL that out. So r1 and r2 are the roots. So what Regina did, I was going to point this out in a second because this is a good example for this lesson. This example could be done with sum and product, or you could just take the roots right here and plug them in for r1 and r2, and when you multiply it out, you'll get fractional coefficients. You just got to clear out the denominator afterward. So either method is totally okay, and you'll get the same answer either way. So yes, I would agree to make this -10/2. Let's go ahead and do that. Okay, instead of -5/1, just so that I can now make the statement that A is 2. If A is 2, then C is -10 from this, and it looks like B is -1 from this. Again, I can just literally line them up. A is 2 here, A is equal to 2 right here. If those are identical, then we're good to go. And then we have to say, okay, well, B must be -1 because it said negative B is +1. And then C must equal -10. So it gives us our A, B, and C values. Okay, so our answer would be y equals 2x squared, that's A, minus x, which is the -1 for B, and then minus 10. So if you did it by multiplying through, you'll get something like this, but if I recall, you'll get something over 2 with one of them, and you have to double everything, right? Is that the final answer you get in blue? Yeah. Okay.
So I started like going over this with my tutor before I learned 7-7,
Okay.
and he was looking at it like you could take the factor of x minus 2 and like flip the sign and then work backwards from there. Like, could you do that?
That's what you're doing by using that form in the top right. So look at the
Oh,
sign.
yeah.
When you put -2 in, so what you're doing by doing that is memorize, which is okay. You can do that, and that helps sometimes. But if you remember the standard form for factor form, which is x minus r1, x minus r2, the -2 becomes r1. It's x minus -2, which is really what you said. It's flipping this sign. The problem with that method is that what happens when you have roots that are 2 plus or minus 3i? Can't use
I mean,
that.
I didn't practice it that
So yeah, no, but it's very good for any time you get real answers for your solution. That's a great idea. Okay, especially when your roots are real and when they are rational. If they're irrational, like 2 plus or minus root 7, or imaginary 2 plus or minus 7i, that method is really tough. and then you want to do sum of product for sure. Sum of product is the way to go when you have roots that are irrational or imaginary. Again, roots that are irrational or imaginary, you gotta use sum of product. When they're rational like this, then I would do what Regina said and what Alex said and use the factor form method, or what you said, Isabella, by flipping those signs there. Okay? I agree with that. It's a good idea, but make sure you know when to use it, right? It doesn't work for all problems. That's one thing Mr. Rusi and I were talking about yesterday when students want to know the answer. Will this always work? And you can never answer that question as a teacher, especially in math, right? Because if I vary a small thing up, now you have to change your methodology. So you don't want to come up with something that you have to use every single time for methods that could be used in place when you have imaginary and irrational, and then another one when you have rational. Alex?
Number 7, 7, 30.
Number 30.
Yeah, it's a vertex of -1 and -10. And then next vertex of -6 and 4. And you have to like form a quadratic function.
Okay. So, yeah, Regina.
I have a question on that problem.
Yeah, go.
Could you leave it as x squared minus 0.5x minus 5?
It said integral coefficients. Write that down. Integral means integer in that case. So when it says find an equation in standard form with integral coefficients, it simply means that a, b, and c should be whole numbers. Okay, it's the only thing, and you're going to see a lot of that because when you write quadratics in standard form, you usually don't want to have to deal with fractional coefficients. But Regina, technically it's right. Yes, that's the correct answer, but you just want to multiply it all by 2. Okay? And you don't have to multiply the y on the other side by 2. You know what I'm saying? Okay, it's still just y equals. So, Alex, the reason this one is a little bit tricky is because the vertex part is there to throw you off. It's just a point. You have the x-intercepts, right? Once you have the x-intercepts, plug them into that root form, and then you need to get the a value from the point. So the root form I wrote down a minute ago. No. The root form I wrote down a minute ago was this, right? The problem is that there could always be a multiplier in front. Remember the a value could always be here in the front? So for this problem, because we have 2 of the x-intercepts, they're both there and they're integers, I would plug them in there and then go ahead and use the vertex as the third point. Because they give you a third point. That third point will allow you to plug in for x and y and solve for a. Let me show you real quick. So when I plug in these roots, I'm going to take this one, oops, right here, plug it in there, take the 4 and plug it in there. This becomes f of x equals a times x minus -6 times x minus 4. But I don't know a, right, Alex? So why do you think that point's given? Whenever you're given an extra point that you haven't used, use it in the function to satisfy the function, because if it's on the curve, it must satisfy the function. So we take -1, plug it in here and here. We take the -10, plug it in right here, and you solve for a. Because remember, if you're going to write a function out, and you're going to write it in factor form, you got to have the a value in the front. Okay, you got to have the a value in the front. This is different than the last problem when it said integral coefficients, right? When it tells you integral coefficients, as soon as you plug the 2 roots in, you got to just clear out any denominators that are left. And then the answer could be anything. Like, last example, let's pause and talk about it. What we're seeing here is that when we plug in for R1 and R2, those 2 values show up as the roots, but we need to know what this a value is. I can't just factor this out anymore and just double everything or triple everything. It doesn't work, because I'm asked for a specific function that goes through that vertex. The last example, we were only told the roots. So you need to be visualizing this. Here's your visualization. Here's one x-intercept, here's the other. This graph could go all the way up, or this graph could just do this. Or this graph could do this. You see what I'm saying, Alex? So no matter what I pick, the height of the vertex can vary. And that's a function of whatever you multiply by. So in the last example, we doubled all the coefficients. And then I said, you can double them again, right? And I showed it in red. That would just make the parabola taller. Every time you double the coefficients more, it extends the vertex of this parabola, making it higher or lower, depending on it. Now, in this case, because we have the vertex, we don't know if it's going to be here, or here, or here. We know it'll be exactly at -1, -10. So this parabola will actually look like this. And here's the vertex down here at -1, -10. So the only way I would have been able to get this answer right would be if I can recognize that since this opens up like this, a is going to be positive. if I don't plug in this point. So go ahead and plug in that point up there of negative 10 equals a times negative 1 plus 6 times negative 1 minus 4. Again, I'm taking this coordinate here, plugging it in for x in both spots, and taking the negative 10 and plugging it in for y right there. Okay, again, I'm just simply sliding these ones into the right spots, into x and into y points. Okay, I got 2 physics students and the rest math. I'm going to come back in a second. I got to go back and forth. The physics, second?
It's part of the same question.
Quick, because the physics is tested. I got to be.
How do you find the b?
How do you find the b?
Yeah, because you know it says like ax squared plus bx plus c.
Uh-huh.
How do you find the b part?
You just multiply it out at the end. I mean, b is the middle coefficient. So if I were to expand this, it becomes x squared plus 2x minus 24. The plus 2x is where the b comes from. Is that what you're asking?
Yeah.
Okay. That could be asked many ways. Like b could be found in other problems as well.
I did a different method.
Did you get the same answer?
No.
You had anything with factors like this?
No.
Talk to Julia next to you. Discuss that method while I go over this with physics, and I'll come right back to you and go through it. Okay. That's what you came here for, lab 14. Let me just send it to you. I'm just going to send it to you. I don't have time to go to the printer, okay? So just fill it out in there and submit it to Drive. It's only 4 questions on the back. You already submitted the videos?
Yes.
Okay. Ann?
Just a problem where it's like the factor, like what factor to change it by. I have trouble with that one a lot.
Absolutely, Ann. Good question.
It's like
Started or?
No, I have like that.
Perfect. Go ahead.
It's find the quadratic function in the form f of x equals ax plus bx plus c for a point with a maximum value of 10 and x intercepts. What does that make sense?
Okay. So the reason this is tough is because the max value is not telling you all the information it should tell you. Where does a max or a min occur? Where does it occur, Valentina? Yeah, right in between the x-intercepts. Because the graph is, fill in the blank, everyone, symmetric. So I need to figure out the overall vertex. So if I'm visualizing this, I draw my intercepts at 1 and 3. The max value is at a height of 10, which is up here. So what's the x-coordinate of the actual max value? The x-coordinate is just 2. It's the average of these. It's the middle point. So that's all we have to use. So once I'm given that, I can go ahead and say, well, the axis of symmetry must be 2, which means the max value is really the coordinate 2, 10. And again, how do I know that? Here's my visualization. Right? If those occur there, and the vertex is at 10, and the max value or min value always occurs at the vertex, it's got to be going right down the axis of symmetry. So there's my x-intercepts, that's a height of 10. I don't know what its x value is, it must be 2. So now I can say it's 210. I've got the x-intercepts. We use the same method we used in the previous example. I'm not going to go through that again. Okay? So again, I'll just put it up so you can see it. And then you go through and plug in the point 210 here and here, and the 10 goes in over here. And then solve for A. All you have to do for that, it's the same problem we did 2 problems ago when you guys asked, where you were given a vertex and 2 x-intercepts. It's the exact same problem. Okay, that's all you're going to do for these. Eduardo.
And in this one, your final answer, x is the variable you don't plug in.
Correct. So what you do is this. Once you get the A value, you go back to this line right here. So yeah, you're going to plug in for x, you're going to plug in for y, you have all numbers except for A. And you just literally write it like this with the A there. Now, because this problem said put it in standard form, ax squared plus bx plus c, you have to FOIL the whole thing out. And then whatever A is, distribute the A to the 3 terms of A, B, and C. So you literally just FOIL it out, okay?
So to find C and D, you just have to FOIL these.
Yeah, well, once you FOIL this, once you get a quadratic in standard form, but then you would have an A, right, outside the whole thing. So you just distribute the A to all 3 terms after that, and that would give you A, B, and C. Same question still?
Yeah.
Okay.
So could I find the sum and product of the roots and just like put those in for B?
But like you said earlier, this is a faster method when you have rational
Yeah,
x-intercepts.
wait, I'm not talking about like the thing where you work backwards. Like I and then like found B in the summing product, and then put those in just put A.
Well, the issue is this. How did you... Oh, so you solve for A by plugging in the 0.210? That works. Yeah, that works. Absolutely. Good point. But Isabella, I actually think this is faster. I think what you said earlier is right. I wouldn't use sum of product unless it's imaginary or rational. If it's not imaginary or rational, this is literally the fastest way. When these are rational roots, you just plug them in here and here. And you're really done. You just have to find A. I think it's a lot quicker, but you can do whatever way you want. Right? Either way works. Totally. You were the one who argued this method earlier. Whether you realize it or not. You did. When you said just use the opposites, that's what we're doing, right? Opposites of these are these. And that's really working your way backwards, like you had said earlier. Alex.
I did it a different way, but I think I got the same answer. I just factored it out, and I didn't plug in like a 2 or a 10.
Okay.
And then I did completing the square, but I still got the right answer.
I mean, how much faster is this than going through completing the
So
square?
for this, you just, I did that just because I didn't like write that too. All you do is just you do the sum of the 2 and the product of the 2.
I didn't even do sum and product here. I used the rooted form, which is given at the top here. That's an F. Do you remember this form? We just went over this, or you listened about it. You can go over it. But I use that form. I just plugged in. This is R1 and this is R2. Remember, roots are x-intercepts. So those just get plugged in for R1 and R2. And then I took the point, plugged it in for x, plugged it in for y, and solved for a. So what do I get for a in this problem? You want to know the negative 1/4? Is that right, or is that incorrect? You didn't get negative 1/4?
I got A equals 10.
I got A equals negative. I got negative 10.
Negative 10? I heard a lot of negative 10s. I heard 10, but I also heard a lot of negative 10s.
Yeah, maybe.
Well, let's see if I plug a 2 in, becomes positive, that becomes negative, a 10 in. It's got to be a negative answer for sure. So let's say that turns out to do it again. Now you just FOIL this out, but then you have to multiply negative 10 to all 3 terms you get when we FOIL it out. I think this is a much faster way than completing the square or summing product. But I would definitely use summing product for problems where you have imaginary or irrational x-intercepts. Let's do one of those in a minute. I'm going to go to physics, we'll come back and do one of those. Yeah. Well, look, if you got a dagger, which was drawn to the right, which vector? F3, 1, right? So isn't that to the right positive? And which vector is pulling left? It's sum of the forces. So we're sum of the forces in the x direction. If I have a push here and friction here, it was Fp minus Ff equals ma. But we're not setting equal to ma because there is no mass needed. There is no acceleration needed. We can do that with an extension of the problem. But we're just trying to find out the net force. So you subtract or add depending on the scenario. If both vectors then were pulling to the right, what would you be doing? Adding. If both vectors pull to the left, you add the negative. So it'd be like negative F31 minus F32. Right? So it'd be like, you know what I mean? It'd be the opposite of the positive. So the negative sign. Katie, you swear on the left? Any questions? What does it say? I asked that question. So I said, do you need anything else? Slide the mass bar over the raise the charge against 100. Well, why don't you just, I'll give you an hint since you don't have to compare the computer. But think about F equals ma.
Yeah, I did.
Like right? Because the F is the same, the force you're feeling is the same, right? That's a function of the sources you placed. So if you suddenly increase the mass, what's going to happen then? That's really what the question is asking. I'll come back to you guys in a minute. Think about more questions there, okay? Is it worthwhile to go to a problem with irrational or imaginary roots and do a sum product? Show me hands if you would like to see that. Okay, it's about half of you. I'll do it quick, since some of you say you don't really need that. So, you have one for me? Sure. Can you give me the roots?
1 plus root 2 over 3 and 1 minus root 2.
The whole thing over 3?
Yeah.
All right, so the reason this looks tricky is because of the setup. It's because you're like, oh, I gotta multiply these and add them, but certain things cancel out. Picked up on that by now? from the homework, or you didn't do the homework for this yet. From the classwork, I guess, you might have seen it. Certain things definitely cancel out, is what I'm saying. So let's take a look at this. So if I want to think about this problem, and I want to take the sum of the roots, to add roots together, I need a common denominator. Well, that already exists. That's why this is nice. Right? The common denominator is already there. So the sum of roots, which is negative b over a, just add them together. What happens to 1 plus root 2 plus 1 minus root 2? What happens to those numerators? What do you end up getting there? Just 2. Again, add this and add this. Those cancel out. So 1 plus 1 is 2. That's the sum of roots. And the sum of roots is always negative b over a. Yes, I see the hand already.
Yeah, for negative b over a, would 2 be positive or negative? Like,
2 would be negative in this case. Yeah, because look, negative b is 2, isn't it? So b is negative 2. But it depends on what a is also. We have to get to the product in there. We have to change things up, right? We need to really see both. Okay?
Like I said, if the product equal like -2 would.
B would be positive 2. Because negative b would equal negative 2. You're equating positions in the portion. The denominator is equating. So a is 3 as of right now. We got to get to the product to see if that holds true. So the product of roots is also, I think, not too bad because of this nature of binomial conjugates. When I multiply the denominators, what do I get?
okay,
9, no big deal, gotcha. But the numerators are real nice. The middle terms, what happens to them? Middle terms always cancel. They always cancel when I multiply conjugates. Whether these are imaginary, where it's like 1 plus 2i and 1 minus 2i. That's complex conjugates. These are binomial conjugates. Either way, they're going to come out to be a whole number. They're going to come out to be a whole number in the numerator. Okay, when I FOIL this out, that becomes a 1. Outer and inner cancel. And then I multiply the last terms. That becomes minus 2. That becomes negative 1/9. So now I can clearly see that a, using a as 3, isn't very good here, right? So what should I do to this fraction? How can I write 2/3 with a common denominator of 9 instead? 6/9. So I would then go back up to here and say, let's just call this 6/9 instead, because that's what 2/3 is, isn't it? And now I can consistently call a 9. Again, the sum is negative b over a, and the product is c over a.
Oh, check out here, none of this is true.
And the actual product is c over a. So in this case, a is clearly 9, a is 9, c is negative 1, and negative b is 6, or b is negative 6. So b and c are both negative numbers in this problem, and a is a positive value. So my answer would be 9x squared minus 6x minus 1. And look, I cannot reduce this by anything. I can't take a 3 out. If this were a 3, I could have, right? But then that wouldn't have had to happen. So by making your equations the same denominator, it alleviates clearing out any denominators you have to deal with. Okay? Another question.
Oh, I was.
You can jump to a different section if you want to get.
On 7-6.
Mm-hmm.
Only 38 was the problem set, but I was confused on 37, 38, and 39.
So 37 through 39 are the ones, and they're all the same kind of problem?
Yeah.
Can you give me one of them?
36.
Alex, you got me? 7-6, number 38.
An exercise 37 through 39 for represented by
Louder, Alex.
Represented by an equation y equals ax squared plus bx plus c is given. Study each graph and then tell whether the value of each expression that follows is positive, negative, or 0. And then they give you for a,
Go ahead.
it's b squared minus 4ac.
Got it.
For b, it's c.
Okay.
For c, it's a, and for d, it's b.
Okay, I know what this is.
37.
What's the graph? Show me with your hand. Is the middle one on there? The middle one? First one?
38.
Middle one? Got it. So we're looking at 38 right now. Does it go through the origin, one of the x-intercepts, or no?
Yeah, it goes through.
Like through, right through, okay? So this is reasonable, Alex? Yeah? Okay. So I'm given this graph, and I'm asked about these four quantities. This is a great question. Definitely a question you can expect in your test. Because this is asking about the nature of the problem. What does b squared minus 4ac tell me about a graph? I know it tells me a lot about the graph specifically. Go. The discriminant. What does that tell me about the graph? If the discriminant is positive, the graph will two x-intercepts. Does this have two intercepts? So what do you know about the discriminant? It will be? Boom, you're done with part A. Okay, and this is asking you, are the values positive, 0, or negative? That's really what it's asking you. So this is positive. I agree. We could say it's greater than 0. Okay, when would it have been 0? Would have been if this graph was tangent to the x-axis, or this way, touches once, and comes back around. That's when the discriminant equals 0. When would the discriminant have been a negative answer? If there were no x-intercepts. So if the graph was up here or down here, that would be when the discriminant equals a negative quantity. So that's part A. Part B says, what about the c value? What did the c value tell you about your function? In standard form, what was c?
I know.
Did I pick up on this? It's in the notes. I'm not sure.
Yeah.
So what does the c value tell you? C is the... Thank you. Y-intercept. You got to look this up. C is the y-intercept. The y-intercept is up here, so Regina is right. It is positive. Then I can look at A and B. The graph opens down. When the graph opens down, what did it tell me? The leading coefficient must be, everyone? Negative. When the graph opens up, the leading coefficient is positive. So part C is going to be, for the letter A, is negative. Again, because it opens down. And then what about B? This is the trickiest one. I got to use the axis of symmetry. That's the axis of symmetry. And isn't it over here? Look at where it is. It's over here, which is on the positive side. So because this is the axis of symmetry, this number needs to be positive. Okay? So as a result, since I know that A is already negative, A is negative from part C, the denominator is negative, the negative cancel each other out, and since I want the answer to be positive, I need B to be positive. I'll go over that one again in class today. Okay? I'll go over that one when we get a little bit of time. Remind me to do another one of these examples with everybody, please.
I said B was positive because of B squared minus 4AC.
Example number 6 in your notes from 7-6. So you want to know how many times a parabola intersects a given line. A given line. When things intersect, what do you know about the equations? They are? What do you do when things intersect? Like if I know the line y equals 2x plus 4 and the line y equals 3x minus 7, if I want to find the intersection, what do I do? Yeah, you set them equal or substitute in. So in this case, if I had, I'm going to pick anything, not the same, okay? If I had y equals 2x squared plus 5x minus 4, and I want to know when it's going to intersect or how many times it intersects the line y equals 8, I want to know how many times it's going to, this is the exact problem, just different numbers, okay? How many times does it intersect the line y equals 8? Well, I can graph it and look at it, but chances are a problem like this is not going to give you a calculator on that one, it'll be a non-calculator. So if I want to know when they're going to intersect, I do what Isabella said, which is substitute the y value in, or just set them equal. So plug that in for y. So that becomes 8 equals 2x squared plus 5x minus 4. And if I want to know how many times it's going to intersect, I can then just solve this like a quadratic. If I get a discriminant that's positive, how many intersections or roots is that? 2. If I get a discriminant that's 0, it means that it's going to intersect the line once. If I get a discriminant that is negative, it means it will never intersect this line. You just said okay, but you don't really get it.
No, I thought you said the same thing twice, but it's just...
Look at the graph of it so you understand also. Negative 4 is the y-intercept, that's down here. I know that it's going to open up. The axis of symmetry is negative b over 2a, which is negative 5/4, so it's somewhere over here. So that means that the vertex has got to be a little bit below. And the graph's going to look like this for this one. Now, If I want to know how many times it's going to intersect the line y equals 8, where's the line y equals 8? It's all the way up. Right? The line y equals 8 is this green line right here. Well, how many intersections are going to occur? Just based on looking at the graph 2. So go ahead and find out the discriminant of this by moving the 8 over. All right, move the 8 over. This equation becomes, and then find that discriminant. That discriminant will guaranteed be positive. Guaranteed. Because I can see on the graph that how many times is this curve going to intersect that line? Twice. When you have 2 intersections or 2 x-intercepts or intersections, we know that the discriminant's got to be positive.
Okay, so like you're basically like treating y equals 8 as your x-intercept.
Yes.
So like your 0, like
Yes.
so like instead of finding like the zeros, you would find like the 8.
You find the zeros of after you move the 8 over. Correct. Very good. Well done. It's as if it's a new x-axis. The green line is like a temporary x-axis. We're trying to see how often this curve, or how many times this curve intersects that green axis.
So just find the discriminant
Of the solved equation. You gotta move the 8 over. You can't just have it like this, right? Because this, if you look at it this way, Sebastian, this is the original function, isn't it? And if I find the discriminant of this, it'll tell me how many times it intersects the x-axis. But what is the x-axis? Isn't the x-axis 0 really, technically? That's why it works when you put a 0 here, you can see how many times it intersects the x-axis. But if I want to know the line y equals 8, instead of setting it equal to 0, I set it equal to 8. And then move the 8 over and find the discriminant as a result. Okay? So let's look at something like example 5 on 7.6 from the notes. Okay, let's say it says, anything else besides changing the R1 and R2?
So for y-intercepts, like, can I skip it?
Yep.
For here, a h squared plus k, would you, like, does that mean like if you have the values of these variables and like if you solve for that expression, would that be your y?
Yeah, and then think about it. You're just setting x to 0. That's all you're doing, right? To find the y-intercept, you always set x to 0. When you plug a 0 in there, it becomes just a, that's h squared plus k. It's negative h, but it's squared.
Oh, yeah.
And you don't have to memorize this. This is
Okay.
just to show you.
Yeah.
But you should know, find the y-intercept, set x to 0. And that looks fine. You don't need to actually memorize that form.
Isn't that the same thing as y minus k equals that one?
Yeah, that's the same as vertex form. Yep, that's what she's referring to there, vertex form. Yep. So let's look at a problem that says the following. Let's say we want to make up our own quadratic function for the following graph. Okay, there's the graph. Give me a quadratic function that can work for this. And after you have no numbers at all. I'm not giving you a scale, I'm not giving you x and y intercepts, nothing. All you know is that's where it's going to occur. So what are some things you know based on just looking at the graph? What can you tell me? Give me something.
The discriminant has to be negative or imaginary.
Good. The discriminant has to be less than 0. Because when you have a discriminant that's negative, the roots are imaginary. When the roots are imaginary, you don't get any x-intercepts. And this graph is a floating graph. I use the phrase floating, meaning it never crosses the x-axis. It will definitely cross the y-axis. Where? Where will it cross the y-axis?
I'm just going off to it because it like sinks a little bit.
So will it be a positive y-intercept or a negative y-intercept?
Positive one.
So that means that C has to be positive. Because C is the y-intercept.
And
And what about A?
A, it's also positive.
Because it
Curves up.
opens up.
Curves up.
Again, the y-intercept is what tells you about C, and this is because it opens up. Okay, A is positive and C is positive for sure. If it opened down, A would be negative. If the y-intercept were down here, C would be negative. Now, the last part, that's the toughest one. Okay, the toughest part is to figure out this this axis of symmetry. Is the axis of symmetry positive or negative in this case? Positive, because it's on the right side. And here's the axis of symmetry, right? It's clearly positive. Say, I don't know, x equals 5, 6, 7, whatever it is. Since it's positive, we know the following. Right? That's what it means, literally. The axis of symmetry, aka negative b over 2a, is greater than 0, meaning it's to the right on the line. Well, we already made a statement that a is what kind of a number? What kind of number is a? So if a is positive, and this is the denominator makes that positive, how can I get an answer to make this whole thing positive? What must b have to be? Again, a positive denominator from A. Right now we have negative b up top. That'll be a negative over a positive, which would be a negative, and a negative is not greater than 0. So b has to be a negative number. And we conclude that from this statement right here. So there's my 3 statements. So give me a quadratic function that works. Give me a quadratic function that works. I need a to be positive. I need c to be positive, but I need b to be negative. I need b to be negative. Right? So those are my 3 parameters. You could pick any numbers, obviously, right? But only certain numbers will work for the first thing, which we didn't really look at yet. Right here. Okay, we got to consider that. So give me a value of a for now. Make it easy on yourself, obviously. 3. Even easier.
2.
Even easier. Thank you. Just for now to start, I'm saying, right? So let's set a equal to 1. B's got to be negative. If b has to be negative, give me another number for b that makes it nice and easy. Negative 1 works. Let's pick a different number for c just because we picked 1 already. So let's go with 2 for c. Does that work for the discriminant? Does that hold true for the discriminant? B squared minus 4ac. Does that come out to be negative? B squared is 1 minus 4 times 2 times 1. So it would be 1 minus 8. And 1 minus 8 is negative 7. So this works. So this equation works. If it didn't, what would you do? Tweak it. Switch it a little bit, right? Vary it a little bit. These are what we call parameters. A, B, and C are parameters. Sometimes you have to change your parameters to fit the condition. So for a problem like this, maybe, let's say hypothetically, right? Let's just say that you told me to use negative 3 for B. Take a look at the equation now. Let's just hypothetically say you said, oh, let's make B negative 3. We don't know, it could be negative 1, negative 2, negative 3, negative 4, negative 5, anything. This becomes 9 now, doesn't it? B squared. B squared minus 4ac is 9. That'll be 9 minus 8. And 9 minus 8 is positive 1. So this would not work. Which in my mind tells me that the b squared term is too much. Again, if I'm trying to check on the discriminant, and I did b squared minus 4ac, this would have been negative 3 squared minus 4 times a times c, which will equal positive 1. This is clearly not correct. I need the discriminant to be negative. So I need this difference to be negative. That means that this is too big. So make b smaller. Or, what else could I do? I can make b a smaller number, so that I get a small number minus a big number and it becomes negative. That'll work. What else can I do?
Make A and C larger.
Very good. Jack up A and C. Take A or C and decrease that value. If I make A 3, now it becomes 9 minus 24. Boom, that works. So I can vary A and C as making them more positive, or I can make B less negative, and as a result, either way, come out with a negative discriminant, which is what I need. So again, this is not one of our answers that would work, but let's go back to the first one that we wrote down, which does indeed work. Okay, so that's the graph, or that's a possible equation for the given graph. This is a possible equation for that given graph. Again, you can make B a C 7, 8, 9, 10. You can keep increasing this number. You can keep increasing this number. But you can't increase this number too much, or else it's going to make it too large and makes the answer positive, unless you increase all 3 of them. But why would you do that, right? Once you get an answer that works, just use that answer. Don't sit there and tweak the numbers to come up with another possible solution for it. From 7.7, we talked about a lot about sum and difference of roots, or sum and product of roots. I even did a whole derivation. You're not going to be held responsible for that. Because remember this long derivation I did, showing where b over a and c over, negative b over a and c over a come from? You're not going to be responsible for that. So don't worry. I like to show that stuff so you guys can see for higher level math what you'd be doing. But consider going from example 1 on in the notes for this.
Yeah, please get water.
So for a problem like this, if we're given anything in this case, it really doesn't matter. Let's complex conjugate roots. Because in the example this morning before school, I did binomial conjugates already, which would be a very good application of sum and product of roots. let's go with complex conjugates. So let's say the roots are 2 plus or minus 3i. Okay, those are the roots, and all you're told is to come up with an equation with integral coefficients. Integral coefficients. So if I'm looking for integral coefficients, I can start by saying the sum, which is negative b over a, is equal to 2 plus 3i plus 2 minus 3i. And that just gives me 4. The sum is always easy for these, right? Whenever the conjugates are finding the sum, the plus or minus kind of just cancel out. So that tells me already that 4 over 1, I'm going to put 4 over 1 for now. I know it's 4, I'm going to put it over 1. I can think of A as 1, and I can think of B as negative 4, because negative B is positive 4, right now, as of right now. But let me get to the product now. If I want the product of roots, and that's C over A, I then do the same thing, but I have to get rid of the plus sign and multiply. The nice thing is that when I multiply conjugates, middle terms always cancel. So this becomes 4 plus 6i minus 6i, those cancel, and then minus 9i squared. I squared, though, is what? Negative 1, which makes this 4 plus 9, or simply 13. So I've got a product of 13 and a sum of 4. Well, I can put 13 over 1, can't I? And I'm going to do that. I'm going to go ahead and put the 13 over 1. I'm going to put this 13 over 1, and that's my product, and that's my sum. Why am I putting them over the same denominator? Why does it matter that these are over the same? And they might not have been. This might have been over 3, right? Had this been over 3 13/3, I'd have to make this 12/3. Again, if this was 13 over 3, this has to also be over 3. Why do the denominators want to be the same?
Because the sum is negative b over a and part of the c over a and 1
Yeah, that's A. If the denominators in both of these cases are A, and both of these are 1s, what is A? A is just 1. And then since I know that the product is C over A, and this is the product, it means that C is just 13. And then finally, since the sum is negative B over A, this will be a negative 4 for B. So what am I doing? I'm equating fractions or equating proportions, whatever you want to say. I'm literally lining up numbers. I'm saying that from this first statement here and here, I can yield negative B over A equals 4 over 1. And then from this statement right here and right here in yellow, I can also yield C over A equals 13 over 1. From those two statements in blue and yellow there, from the two statements given in blue and yellow, I can deduce that A is equal to 1 in both cases. In the second case, I could say that C is equal to 13. And over here, since negative B is in the numerator and that equals 4, then B is equal to negative 4. So my answer for this problem in the end, I'm done at this point, would be y equals 1x squared, which you don't need the 1, minus 4x plus 13. Now, all that was given to you in this problem were the roots of the equation or function. All you were given were the roots of the function. So, again, we emphasize, I can double every one of these and get the same roots. Logically think it through right now in your head. If I double all of these, and then I want to find the roots, to find the roots, what do I set this equal to? 0. And if these are all doubled, what can I then factor out? If they're all hypothetically doubled, I can factor out the 2. And if you have a 0 equals 2 times this whole thing, when you factor out the 2, what happens to the 2? When you factor out a number and it's equal to 0, what happens to that number? Is anything happen? It goes away. You divide by 2. 0 divided by 2 is 0. So what I'm trying to emphasize is this. For all of these problems where you're only given the roots and not a vertex or a max value or a third coordinate, if you're only given the roots, you have an infinite number of answers possible. I can double all of these, I can triple all of these, I can quadruple all of these, and you get the same graph. It's just that the graph, instead of looking like this, It gets stretched vertically, but it still has the same x-intercepts. I can't draw it here because the x-intercepts are imaginary. So this would not be a good example for me to draw you a graph right now. But physically, in your mind, that's what's happening. Okay? I can multiply this by any constant scalar, by any number, and get the same results for the roots. We have to know about symmetry. We have to. It is useful in so many ways. It's useful when I need to graph and I'm reflecting another point. It is very useful also if I were to only tell you the two roots and then give you a problem with like a minimum value or maximum value problem.
I'm confused. How do you state the axis of symmetry?
X equals whatever the number is, because it's a vertical line. Horizontal lines are y equals, vertical lines are x equals. So I always go to x equals negative b over 2a. That's the formula for axis of symmetry. Plug in b, plug in a, get a number, and since it was x equals negative b over 2a, it's x equals whatever that number is. Okay, always x equals.
So in the notes, when we found the infinite number, when we found the equation for the roots, you set the equation, like the final equation equals 0 instead of y. So like, if you're asking for the equation at the end, could we write equals 0 equal y? Like
If it says you're finding an equation, you set it equal to 0. And that's what I said in the notes, right? But if it talks about finding a function with those roots, then you write f of x.
So then when do we set it to y?
Either one, f of x or y.
Okay, so y would be if you're finding a function?
Y or f of x is when you're finding a function. But when you're trying to come up with an equation that satisfies those roots, you set it equal to 0 because it's only an equation, it's not a function.
So what we just did was an equation, right?
What we did, it depends on how I wrote the answer. I honestly don't even remember my wording.
You wrote y equals.
All right, so back to this question here. If I tell you that the x-intercepts are 1 and 7, the x-intercepts are 1 and 7, and the vertex has a value of negative 12. The x-intercepts are 1 and 7, and the vertex has a value. Now, mind you, the vertex is a coordinate, so clearly not getting everything, right? The vertex has a value of negative 12. Where would that vertex show up on this graph? The value is negative 12. Regina.
That means that like the would be
I'll start here. Tell me where to go.
go lower down.
Okay? And that's where the vertex is, right there? These are my x-intercepts, Regina. Think of symmetry.
It's going to be
Just tell me in words, John. Give me a number.
in between 1 and 7.
Very good. Equidistant, there's my vertex right there. Let's make this clear. If I tell you the vertex value is negative 12, Regina was on the right track to start. That means that it's down here around negative 12, right? There's 11 and 12, let's say. And then I have to find the midpoint between the two roots, which is right smack in the middle. So again, the value, I could say the minimum value of the function is negative 12. You might want to write these words down, right? They're all interchangeable. The minimum value of the function is negative 12, or the vertex has a value of negative 12, or the vertex has a height of negative 12. Those are all giving you the y-coordinate of the vertex. So yes, this point is 1, 0. This is 7, 0. And this is something comma negative 12. It's a question of what is that something that I need in order to come up with this function. So what does that value become? It becomes the average of your roots. The average of your roots. Why? Why is it the average of your roots? No? Why is this going to simply be the average of these two numbers? Why is that value going to be that? Yeah, the axis of symmetry is essentially the average. That's what it is, right? It's the thing that goes right down the middle that splits the graph in half. And as Helen said, the vertex always lies on the axis of symmetry. So the x-coordinate will be whatever the axis of symmetry was, which was 1, 2, 3, 4. And I can find that by 1 plus 7 is 8. Divided by 2, I get 4. Symmetry, symmetry, symmetry. Okay, so this becomes a 4 right here, comma negative 12. Now, This is a word problem where I'm giving you the intercepts and then I told you only the minimum value was negative 12 or the vertex value was negative 12. Once you deduce the x-coordinate of the vertex, once you come up with this, now you've got 3 points. Now, because the x-intercepts are rational numbers, I talked about this morning for those that were there, when the intercepts are rational, go right to root form, or factored form, sorry. Go right to factored form. And factored form tells me which then becomes, and how do I find out what A is? Whenever you need the last parameter, Eduardo, what do we do?
You plug in the 4?
Yeah, plug in the point. 4 goes in for x, and what about the negative 12? Where's that?
That goes for y.
Yeah, right here. And then solve for A. And then solve. What kind of an answer will A be? Guaranteed. Guaranteed. What kind of a number will A be? I don't care about the number itself. What kind?
Positive.
How come?
Because it's shifting, or it's
Opening.
up.
Very good. Well done, Alex. Look at the graph. It opens up. I can sketch it if I want to at this point, and it's pretty I'm confident in my sketch. I know that my sketch will look something like this and this. So I know already that I will definitely have a positive A value. I also know that there'll be a positive C value. But this problem isn't asking me for in standard form, so you know what? There's no need to do that. Unless the problem says answer in standard form with ax squared plus bx plus c, there's absolutely no need to FOIL this out. You do not have to FOIL this out. It's an extra step. It's extra work. Don't do the extra work. Okay, it's not useful. It doesn't make any sense for that kind of a problem. So again, plugging in for 4 for x and negative 12 for y. Solve for A, and then rewrite it like this right here. Rewrite it with whatever the A value is. Again, leaving y and x in the equation. So my final answer will be this. Right? Oops. It will be y equals some number, x minus 1, x minus 7. And where does that number come from? It comes from plugging in a 4 here and here, and plugging in a negative 12 here. And the rest of the equation, we just have to go through and solve. What would A become? Did anybody do it? Just curious.
4 over 3.
Thank you. And I shouldn't have boxed an A. Sorry, A is not your final answer, obviously. A comes out to be 4/3. I'm going to trust Julia for the sake of time, and because I do trust you. 4/3 is the A value. Leave it like that. I know it looks messy, but who cares? Who cares? Unless the problem says in standard form. Unless the problem says with integral coefficients. If that said integral coefficients, what should I multiply to get rid of the fraction by? By 3. But then what would that do? That would stretch the graph, wouldn't it? And then it would no longer have this vertex. So a problem that gives you the vertex and x-intercepts is not going to ask about integral coefficients. Remember, integral coefficients are only going to show up when you're only given the roots. The minute you're given a vertex, a third point, a y-intercept, you can no longer come up with integral coefficients automatically. Okay, because again, I multiply this whole thing by 3 now. Sure, it gets rid of that, and now this becomes a graph that stretches a lot more. Okay, and you no longer have that as a vertex.
You said that you know for sure the C value is going to be positive. How do you know that?
Because the y-intercept is the C value always. In standard form. In standard form, right? It's not in standard form right now. I get that piece. But C is always the y-intercept. How do you find the y-intercept? You set x equal to? And what happens to those first 2 terms in the quadratic then?
Oh.
You see how that works? Again, watch. If I want to find a y-intercept, set x to 0. These 2 drop off right here. And you get y equals c. So c is always the y-intercept. And because I look at this graph and it's continuing up at an angle, it's going to cross the y-axis at some positive number, right? So c has to be some positive number then as a result. If the graph were inverted, then c would be negative because the graph would most likely come down and cross on the negative y-intercept. Yeah?
But isn't the vertex below 0?
The vertex, though, I'm talking about the y-intercept. The vertex is down here, if the vertex were above and the graph opened down, then C would be negative. But because the vertex is down here and the graph opens up, and
Okay, I get it.
if the vertex were switched, then C would be switched also, yeah. You can definitely get a different C. But for this graph, I'm saying, because I can extrapolate this line, this would continue, wouldn't it? And eventually it would merge with, or cross the y-axis up there. Okay? I want to do some word problems also because those are the end of 7-7, so I want to get to that. I don't want to ignore that. But I do want to start by quickly looking at some stuff. Yeah?
I just had a question about 30. I couldn't figure out how to finish.
30. Which one was 30?
Only one group.
Which one was it that we just did? I did a couple in the example, if you recall. One with a house with maximizing area. Another problem with finding the max height of a baseball or a projectile. And then finally, finding the maximum, I think, cost.
Yeah.
Cost of the video game? Yeah. Reduction of the cost function. So for all of these problems, what can you generalize and say? When you want to maximize a quadratic, what are you looking for? Is the key. The vertex. Again, let's think about this. For any word problem I give you, it doesn't matter what it's about. You had a geometry one, you had a physics one, and then you had a business related one. 3 different problems, completely unrelated, all the same methodology. So, if I give you any problem, and let's say hypothetically, it comes out, and by the way, to find a max, what does A have to be? What kind of a number? If you're maximizing a function. A's got to be what? Yeah, because it's got to open down to get a max, right? Stay with me here, right? If I ask you to find the minimum of that function, then A's got to be positive. So think about the function itself. So let's say my function is this. Let's say this is a height function. Sorry, and I want to maximize height. Okay? There's my height function. Again, as Valentina said, I have to have a negative A value. So already, what do I know about this if I'm graphing? I'll get into the maximization, but graphing, I need to be able to visualize. Isabella, go.
It opens downward. And
Good.
Y-intercept is -7.
Good. I would probably go with the y-intercept at -7 first to start. Now, I know it opens downward. I don't know about the axis of symmetry yet, so let me find it before I go into any more graphs. If I knew the x-intercepts, I could graph them, but that's kind of all I know right now. And Isabella's right, but look, ready? Watch. I can do this. That opens down. That opens down. That opens down. I can put one where it goes like this and opens down. So there are many options still, right? You see what I mean? This graph could look like anything still. So let's go ahead and think logically, though. Let's say the graph looked like this. And I wanted to find the max height. It's right here. It's the vertex. So whenever you're maximizing in a word problem, again, as Isabella said, you need the vertex. But unfortunately, this isn't in vertex form. So I can't just use HK. HK is nice, right? It's in vertex form. I can't do that. How do I find the vertex when it's in standard form? How do I find the vertex in standard form?
You can complete my score.
Too much work. Too much work.
First you find x by
You
negative.
could. You find that?
Find x by negative b over 2a.
And then?
And then once you find x, you plug it in for h, and then we're plugging
For x, to get h.
H would be 0.
Very good. So again, this is always going to be the max height, but this is always negative b over 2a. Always. The x-coordinate is always negative b over 2a for these problems. And yes, this will be, we'll call this h max. Okay, that's what that coordinate always is for an h problem. But how do I figure it out? As Christian said, if you want the y value, you need the x value, right? And the x value is pretty easy to find if you use the axis of symmetry. So that would be negative b over 2a. That'll give us 1/3 for x. So already I know that this will be 1/3 right here. And I need to figure out the question mark. Okay, because again, 1/3 tells me nothing. You know what 1/3 tells me? It tells me the x value that will give me the max height. That's great. But the problem said, what is the max height? Which means I want the y value. I want the y value. You know, in your notes yesterday, you found the x value, which was like the width or the length of the rectangle, to give you the maximum area. So the x-coordinate was simply the width or the length, depending on which way you approach the problem. The y value is the max area. It's always the y value that gives you your maximum value or your minimum value. The x-coordinate just tells you when it will occur. That's all it's telling you. But it's the y value that matters most. So let's take 1/3, and we take that 1/3, and we plug it into the function here and here. So I've got -3 times 1/3 squared plus 2 times 1/3, which is 2/3, minus 7. And this is just going to become a little bit messy. That's all that's going to happen. 1/3 squared is 1/9. -3 times 1/9 is going to be -3 over 9 plus 2/3 minus 7. Well, -3 over 9, that reduces a little further. -1/3 plus 2/3 minus 7. That'll give me 1/3 minus 7, which is -6 2/3. Obviously, I drew this problem up right now, right? You're not going to have an answer where the max height is -6 2/3. Is that logical, what I'm saying there? If I'm asking about a physical height, your answer will be positive for max height. We're not talking about going below ground level, what we say there. So again, this graph would just look like this, just based on our answer. The graph has to be below the x-axis, okay? Because the y value is -6 2/3. So this is -6 2/3. This is 1/3. Okay, it's got to be below here. So this was not a perfect example to use. I'm trying to show you that you can use any arbitrary number to practice this methodology. Okay, practice this. In 7-7, I gave you guys homework, some of which were problems. I gave you 3, 5, 11, and 13. Now, I would absolutely recommend, besides finishing the problem set up tonight, trying to get through the homework or maybe even a couple of word problems for 7-7. I mean, tonight you have to finish your problem set and technically do 7-7 homework. A lot of you did 7-7 already, which is fine. If you don't get to the 7-7 homework, that's not the end of the world. But try to get it to me, or get it to me by Friday for sure. Is that clear for the 7-7 homework? I don't care if it's a day late for that. I won't mark you off. But try to get the problem set finalized for tomorrow so you have a firm understanding of things. But if you want to finish the 7-7 homework, you know, the night after, that's okay. But look at the word problems for sure. Definitely look at the word problems because they're going to show up on your test. I'm telling you now, you'll have at least 2 word problems. Okay, of which I might give you 3 and say choose 2 of 3. I might. Don't bank on it, but I might do that. I haven't made the test yet. I have to figure that piece out if I want to. I'm trying to think of other stuff that I didn't cover yet that was covered in the notes and things that we want to look at. A lot with the axis of symmetry, you noticed. Examples 4, 5, and 6 of 7-7 all use the axis of symmetry. Example 3 talks about a graph where you only have the minimum value and the x-intercepts. Example 2 talks about products and roots, sum and product of your roots. Let's go to vertex form for a little bit to quickly reiterate that, okay? Because that's something we haven't seen for a while now. So vertex form can be written 2 ways. Method 1, method 2. Just move the K over. I don't care which way you want to think of it. I really don't. Doesn't matter to me. If you want to write it the first way on your test because that's the way we started when we did that calculator thing, that's fine. If you want to write it the second way because it's a function notation and we've seen it with functions lately, that's fine as well. But it's key to recognize that the K value is different based on where it is. It's different based on where it is. So let's say I have a problem that tells me the vertex of a quadratic is located at -2, with a value of 5. The vertex is located at -2 with a value, keyword, value of 5. The vertex is located at -2 with a value of 5. Give me one more second. If a point P is on the curve, and that point is, say, 1, 3, determine the equation in vertex form. The appropriate methodology here, I'm going to use the second method, it doesn't matter, would be this. Y equals A times X minus H. H is -2. And then it's plus whatever K is there. Then you would plug in the 1, 3. The 1 goes in for X. The 3 goes in for Y. You go about the process of now solving for A. Once you get the A value in this problem, you finish your answer. with x plus 2 squared plus 5. A would be, let's see, that's going to be a 9. 3 minus 5 is negative 2. Negative 2 over 9. Okay, A would come out to be negative 2/9. Another good example to look at. You notice, right, there are so many ways for me to ask these questions. So you need to be adaptable. You need to be thinking with a malleable brain tomorrow that you can change about on the problem itself. If you want, if you need like 10 or 15 minutes after school and you want to come by, I'm happy to go a bit late to baseball today. Okay, so you want to come after school for about, I don't know, 15 to 30 minutes and then come by today after school, okay? Get some rest, you. You hear me? You gotta get some rest. I know you're not feeling well right now, even if you need to go home early or something, but you gotta get rest, okay? It's gonna get worse. Probably what?
I probably won't be doing all the 7 work.
So do the problem set for tonight.
Can I just do the problem, like, I'll do, like, is it okay if I do some of the word problems for it, and then just submit the rest of it this Friday after?
Submit it all on Friday. I'll change the due date to Friday on Google, okay?
I have to retreat on Friday, so is it okay if I submit it once I have it on Friday?
You can do it maybe Thursday night. That'd be
Yeah,
better.
actually, yeah.
I'll do that. That's better.
Oh,
Oh, good trip. Thank you very much. You're good on the date, right? April 7th, you know? Awesome. Thanks, Francisco. I appreciate it.